Let's get some practice understanding variables and the negative numbers that they might represent, or the positive numbers. So we're told to order the following expressions by their values from least to greatest. And they've given us these three expressions, q minus n, and n minus q, and then they plot n and q on the number line. So just to get our bearings, let's see, this 3 hash marks to the left of 0 is negative 3. So each hash mark we must be going down by 1. So this must be negative 1, negative 2, and then this is negative 3. And then so as we go to the right, each hash mark must increase by 1. So 0, 1, 2, and then 3. And then this just helps us get a little bit more bearings. But let's just think about each of these expressions. So this first one is q minus n. And q is to the right of n on the number line. We know that q is greater than n. So if q is greater than n and you're subtracting n from q, it actually doesn't matter if they're both negative or both positive, one's negative, one's positive. Just the fact that we know that that q is greater than n, that means that q minus n is going to be positive. And if you actually want to look at this particular circumstance, q is positive, n is negative. If you subtract a negative, you're going to essentially add a positive. So this value right over here, not only is it going to be positive, it's going to be a positive value greater than q. And if we had to compare it versus q, we would know that it is greater than q, but they don't ask us to do that. Now we have n. N is a negative value. It's a negative number, and it's a negative number between negative 1 and negative 2. It looks like it's roughly, it looks like it's approximately negative 1.8. We don't know for sure, but if we just eyeball it, this thing is negative, and it looks like it's approximately negative 1.8. Now what's n minus q? N minus q. So it's going to be the negative of q minus n. So n minus q, we have the smaller number, and from that we're subtracting the larger number. So this thing right over here is going to be negative. So the largest of these values is definitely going to be q minus n, which is going to be positive. And then we have to figure out which is going to be more negative, this n value or this n minus q value. Well, let's think about it a little bit. We could just try to approximate what q is, and if we look at it, q looks like it's approximately, this looks like roughly 0.8, and this looks like it's approximately, we've already said, negative 1.8. So if we make those assumptions right over here, this thing is going to be approximately negative 1.8 minus 0.8, which is equal to negative 2.6. So when you look at it like this, you clearly see that this is going to be more negative than this right over here. So this is the smallest, and this is the largest, or the greatest, I should say, maybe. Or maybe let me call this the least. That might be the least, because sometimes when people say small and large, they're referring to absolute value. But let's say this is the least, and this is the greatest. And so if we wanted to order them, we would go n minus q, and if you're doing this on the Khan Academy exercise, you can actually click on these and move them around. But if we can't, it'll be n minus q, which is the most negative. Then you have n, which is still negative, but not as negative. This is roughly negative 1.8. This is roughly negative 2.6. And then q minus n, which is going to be roughly positive 2.6. So this is the greatest. And so let's do the next question. Order the following expressions by their values from least to greatest. So once again, kind of same drill, although here each hash mark looks like it's a half because it takes 2 to get to 1. So this is half, this is negative 1/2 right over here. And we want to compare a minus b to a minus 0.5. So all of them were either a, you could even think of this as a minus 0, right? That's the same thing as a. So let's see. In all of this, we have an a and we're subtracting something. Here we're not subtracting, we're subtracting 0. I guess we're subtracting nothing. Here you're subtracting b, and here you're subtracting 0.5. So in general, the more that you subtract, the more that the smaller it's going to be. So let's see. In which of these cases am I subtracting the most? Well, here I'm subtracting a positive number. Here I'm subtracting 0. Here I am subtracting a. B is a negative number. Here I am subtracting a negative number. B is negative. This is clearly positive. So if you subtract a positive number from from A, you're going to get a lower value than if you subtract a negative number. In fact, if you subtract a negative number, you're going to add to A. You're going to get a number greater than A. So the least is when you subtract the largest value. So or the greatest value. So A minus 0.5. We're subtracting a positive number there. We're subtracting 0.5, followed by A, where we're not subtracting anything. And then you have A minus B. This right over here is going to be the greatest. Why is this? Well, we know that B is a negative number. Notice it's below 0 right over here. So if B is a negative number, you subtract a negative number, you're actually going to get a value that is greater than A. Let me make it very clear. This value right over here is going to be less than A. This value over here clearly equals A. And this value over here is actually going to be greater than A. So now we've ordered it from least to greatest. And once again, if we were doing it on the Khan Academy exercises, we would have a little tool where we could click and move these around. But this is the least, followed by this, followed by that. Now, another way that you could do it, just like we did in the last example, you could try to estimate roughly what these values are. B looks like it's, I don't know, it's not exactly, it looks like it's about negative 0.2. So approximately negative 0.2. Remember, this is negative half. This is negative 0.5. A looks like it is approximately, I don't know, negative, 0.7, negative 0.7. And so you could actually do it with the actual values if you like, but you would get the same result.